hit the record button here. That's Sir Isaac Newton, and he was a reasonably intelligent guy. Before there was Newton, there was Galileo, and before there was Galileo, there was Aristotle, right? So we'll do just like a brief, but not too long, history of science and scientific thinking, which is always what students really want to get into. They don't so much want to learn fancy formulas and see flashy demonstrations, do you? You more want to get into, I think you more want to get into the history of science, right? And not actually do science. Okay, good, I'll skip the demonstrations.
Nah, you can.
Just kidding. Okay, so Aristotle basically believed that you could do science by not really doing experiments and investigating things and asking questions. You could just look at the way it was. This is kind of like the way my stepfather worked too. Okay, you could just sort of look at the way it was and then declare that that is the way it is, that it is the way it seems, right? Yes? And there are a lot of things that are that way, but there are some things that are not. Okay, Mr. Duggan was giving an example. I thought this was good. Like, for example, if you leave grain in a place and there are rats in there, Aristotle believed that grain could turn into rats. You guys ever seen those pictures like where rats will get into some grain? What happens? They eat the grain, they reproduce, and you get more rats. And eventually you've got this room full of rats. It's really very scary. I think I've seen videos of this, right? But of course, we understand what's really happening there. Grain does not become rats directly, right? There's sort of a thing that goes on in between, right? Okay. How about this? Aristotle saw frogs emerging from the mud in the spring. And he said that warm mud generates frogs. Because, it does sort of, right? Of course, they hibernate in there in the fall, and they emerge when it gets warm, don't they? Okay. And Aristotle said this about motion. Okay. He said that objects tend to remain at rest. It is the nature of objects to sit still. Here is a stool. It is sitting still. Now, I briefly made it move. I don't know if you saw that. I animated it, didn't I? I am an animal. I am capable of animating things. And then there are inanimate objects which they don't move. Move, you stool. Move, I tell you move. No, it won't move, right? But I can animate it briefly. Watch. But it stops. Yes? The nature of the stool, this is Aristotle. Don't write this down. Okay? The nature of a stool or any inanimate object is to sit still. Right? If I hit a racquetball and smash it in a room and then just sit there long enough, doesn't it eventually come to rest on the floor? It takes a long time though. That's fun. You'll get hit like 7 times, like behind the ear, before it actually comes to rest. So here it is. If I push it, it stops. If I push it, it stops. The nature of objects is to sit still, right? Does anybody here have a more modern reflection on that? Is it really the nature of that stool to sit still? Yeah, there's friction that stops it. What if there were no friction? What would it do? Yeah, it would keep going. In fact, I don't know if you noticed, but it actually went some distance after I let go of it. Its momentum carried it despite the friction force, right? So we hopefully by the time you get to my class, you've at least sort of seen Newton's laws and you are aware of this notion that that's really not the way it is, right? That there's a better explanation, right? Okay. So Galileo actually did science by experiment. Aristotle also said this, right? And this is notably Aristotle got in trouble, and the story goes like this, right? Because see, what the deal was the Pope said at the time, who was a friend of Galileo's, the Pope at the time said, look, Aristotle is right, and if you don't believe in Aristotle, then you don't believe in the church, right? And Aristotle said that objects twice as heavy fall twice as fast. So if I take 2 pens and drop it at the same time as 1 pen, when this hits the ground, this will be halfway down. Yes? Because it's obvious, right? There's more force acting on this one, isn't there? Let's try an experiment. This is, by the way, modern thinking, to test an assumption, yes? Let's test it. Ooh, that didn't work so well. Let's try it again. No, it seems like when this hits the ground, this one's not halfway down, is it? Seems like they're hitting at the same time, right? So the famous story is that Galileo did this with 2 grapes and 1 grape and just showed the Pope. He said, look, he's wrong, right? And Galileo was not graceful about the way he questioned the Pope, right? And was, I would say, somewhat disrespectful. And eventually it got to a point where the Pope just said, look, you're going to go to hell if you don't disavow all this science stuff that you're doing. And, the planets going around the sun, that's pure nonsense and all this stuff, right? And so Galileo actually, near the end of his life, was in house arrest. right? Because the church was the authority in the land. And luckily, the church, and when I say the church, I mean the Catholic Church, because that's what it meant at the time. The church has gotten out of the business of doing science, which is probably a good thing, right? And I think there was some archbishop that said the Bible tells us how to go to heaven, but not how the heavens go. Which I thought was sort of an interesting thing, right? Yeah, I don't know. Okay. So rate of fall, moving objects. And what Galileo said about moving objects was this. He said that objects tend to keep going. Objects actually tend to keep moving. If you push an object, it's going to move and it's going to go forever unless it's stopped by some other force. Yeah? Objects have something called inertia. And this is Galileo. Galileo invented this. This chapter is about Newton's laws, but this is Galileo, right? Objects have inertia. Galileo, Galileo. Now, this is interesting. You have to believe that objects have inertia. Now, inertia just means that objects will tend to, if there's no friction, objects will tend to do what they've been doing. If they're rotating, they'll keep rotating. The Earth has been rotating, presumably, for 4.5 billion years. There's not a little motor inside there. We won't take apart the Earth and see a little clock motor, right, that somebody reaches in and winds up every now and then. No, its own inertia keeps it rotating. The Earth has been moving 19 miles a second around the sun. The sun's gravity has changed the direction of the velocity, right? But the actual momentum just keeps going, right? Its energy just stays there because there's nothing to take it away, right? What Galileo did, and the way he approached this, and this is just of historical significance, so you don't need to write that down, is that he would roll a bowling ball down an incline like this, and he'd roll it down a steep incline across the level and then up an incline of lesser gradient. Yes? Okay? He would discover that the rule was, and what do you think the rule is? If we roll it from here, where is it going to roll? It's going to roll a greater distance on this incline. Where will it stop? Any guesses? Over the edge? Here, I'll draw this even longer. It will stop on this. The middle? Say it loudly. At the same height. Yes. Does that make sense to everybody now that Braden said it? That it's going to end up at the same height. Because if it ended up, by the way, with no friction, now with friction it doesn't go quite as high. Without friction, it would go exactly the same height. And here's why. Because if it went lower, you'd say, well, where'd the energy go? And if it went higher, you would have gotten energy from nothing. And we know that's not possible. So, I mean, that's like the next chapter, but there it is, right? Okay. So yeah, it rolls until it reaches the same height. Since this is a longer incline or less gradient, less of a slope, it goes a greater distance, right? Now, what Galileo said is, look, what if we get rid of the incline? What if there is no incline? When will it ever reach the same height? It never will, so therefore it'll never stop. That's kind of an interesting way to get at it, isn't it? I think. I don't know. Okay, so what Galileo says is, if we can get rid of, where's the nozzle? If we can get rid of the air friction, then, if we can get rid of the friction with air, he didn't say air, but the object's going to go forever and ever. So here I've got an air source. I'll put it right here. Isn't that like an 80s band, Air Supply? All right. And this is, people always ask me, how do I style my hair and stuff like that? It's like, okay, now, kids, I'm going to attach this to the air track. And now the air is going to come out through little holes in the surface. Okay? And and as you can see, the object is now, what? Excuse me, you need to concentrate here. Okay. The object is now floating on a film of air, which eliminates the friction between the air track glider and the surface. Okay, sorry.